Hi everyone, welcome to today's video. In today's video, we will talk about something called Driving Scenario Toolbox in MATLAB. So this Driving Scenario Toolbox is a toolbox used for a lot of things during development of autonomous vehicle. So the main advantage of Driving Scenario Toolbox is you can create an environment which consists of road, which can consist of other vehicles or other actors such as pedestrians or bicyclists, and you can test your vehicle or your control strategy in this kind of environment. So in autonomous driving, there are three very crucial stages. One is perception, then there is planning, and then there is control. Perception is done based on the present actors and the present objects around, and planning is done based on the motion of these actors and the lanes available, and what is the vehicle speed, and a bunch of other things. So how the Driving Scenario Toolbox helps is it helps you create road model, it helps to create actor model, then configuring vision, radar, lidar, and inertial measurement sensors, for example accelerometers. Then it can help to generate actor boundary detections. It also helps to detect lane boundary detections, then point cloud data in inertial measurements. You can also load pre-built driving scenarios such as ASAM OpenDrive, OpenStreetMap, here HD Live Map, etc. etc. The interesting thing is once you have modeled your driving scenario or your environment, you can export these objects such as road network, then actors, and the trajectories to the standard open scenario file, ASAM standard open scenario file. You can also export synthetic sensor detection to MATLAB, and you can use this to test your perception algorithms. Then you can also generate M code out of scenarios and sensors. You can programmatically modify scenarios and import it back into the app for some different sort of simulation. You can also generate Simulink model from scenario and sensor and use the generated model to test your sensor fusion or vehicle control algorithm. Alright, so with this let's get started. So what is benefit of this simulation? So it's time and cost, and yeah, so let's get started. So this is Driving Scenario Toolbox. How you can reach here is you can go to apps and you can go to automotive section and you will find this app there. This is how the app will start. So let's add road. For road you can click here and you can drag up to the point where you want the road to be, and then press double click and the road will appear. Now what you see on the left is essentially metadata, or not metadata but in fact data that describe this road. Okay, so this is just name of the object, this is type of the object, okay, and this is name of the object, this is width. So instead of 6 meters, let's define it to something like 12 meters, which will represent sort of a 4-lane road total. And let's keep road segments to just one. Move on to lanes. Let's create a two-way road here. So let's keep lanes You can define line width, lane type, okay, lane marking. Let's change this to what you generally see on the highway. Dashed, and select something like double solid, give it a yellow color. Yeah, that's all. Now if you want to introduce a turn here, you can click here and add a road center. You can give a path, curvature here. Also, if you want to extend road length, what you can do is you can go here, click here, and yeah, so you can see that it has started, it has given an option to extend the road. So let me extend road this way. Okay, and once you are done, you can just double click. Yeah. Alright, you can give a banking angle to the road and bunch of other things. Now let us also create a cross section here. So for that we can go to road and we can create something like perpendicular road. Okay, let's give same properties to this road as well. So okay, 12 meters, lanes 2, yellow color. All right. Well, just to make it interesting, let's give it also a curvature at the end. Let's extend this road. Alright, so you can zoom in and zoom out using your mouse scroll. 1 and 2. That's all. Alright. So you can see that cross section has been created here. Alright. You can click this home button to fit it to the view, and now let's add our R vehicle, which is referred to as ego vehicle. So I'm adding a car. You can see that by default the first vehicle is set as ego vehicle, and you can set properties. So let me put my vehicle here. Yeah, you can see that the vehicle is here, but you can see that the orientation is not right. By default the vehicle comes in this vertical orientation. What you can do is you can click on the ego vehicle, go to actor properties, and you can change the yaw angle. So I'll set something like 360 minus maybe 20. Okay, so must be a scalar numeric value. So let me put 340. Okay, vehicle seems to be aligned. Also, you can go and change this car to truck. You can see how the height has increased, the length has also increased. Also, you can change it to different models like hatchback, sedan, compact SUV, or just a box truck. Alright, so once actor properties are set, you can also change length, width and height of the vehicle. You can modify front overhang, rear overhang. Okay, alright. There is also an option to change the radar cross section. We will not make any changes here at this point. Now do the interesting thing. Let's see the trajectory. What is the default trajectory here for this vehicle? Alright, so you can see that there is only one point which is basically mentioning vehicle's current position and the orientation. Default speed is set to constant speed of 30 meters per second. Let's add some waypoints. You can right click on the vehicle. And select forward points. So let's give it a trajectory. Alright, so after double clicking, it starts to populate this table according to the waypoints we have given, and it has back calculated what yaw angle vehicle will have at all these points. You can see in the yaw column all the yaw angles are populated. Wait time is 0. Vehicle is not stopping anywhere as of now. Vehicle speed, you can see in meter per second, is constant, and the XYZ coordinates of the vehicle are also back calculated. Now let's just run this and see how it looks like. On the right hand side we have a perspective view of the vehicle. Alright, so now let's do one other interesting thing. Let's add one more vehicle coming from the front, from the other lane. Let's place it here in the beginning, and as you can see the orientation is vertical. What we can do is we can go to actor properties, and also let me minimize the radar cross section. Alright, let's give yaw angle. I think in this case yaw angle of 270 should do. Alright, okay, and now let's give it some waypoints. Alright, okay, that's it. Let's smoothen these out a bit, so the simulation does not look too jerky. Alright, as you can see, the waypoint and all the other values like yaw and position, speed, everything is populated. Speed is again constant in this case. We can modify the speed from here, so let's slow this vehicle a bit down, or let us speed it up. Okay. Alright, so speed has been updated. Let us just run this simulation. Alright, so as you can see, since this vehicle is faster compared to ego vehicle, the simulation stopped as soon as this vehicle reached here, because it is end of road for this vehicle. Now let's do one more interesting thing. Let's say that if I was actually driving this ego vehicle, what I would really do is, if I saw a cross section and a vehicle approaching so fast, I would actually slow down around this waypoint, or probably this waypoint. So let's make our ego vehicle wait at waypoint number 3. Alright, so you can see that waypoint stop time is 0. Let's make it 1 second. Okay, let's wait till the system updates. Okay, so what it has done is it has reduced the speed to 0 at this point. Let me also wait at next waypoint for something like 0.5 seconds. Okay, alright, this waypoint is invalid, because what it means is vehicle will just not move, because just at the next waypoint I am setting wait time to non-zero. So let me just increase wait time here. Alright, now one problem with this setting would be that our ego vehicle will stop here, okay, for 3 seconds, and within that time this vehicle is going to finish its journey. Okay, so what we can do for that is we can increase length of this road for this other vehicle. So let's do that. Let's select road number 1, and what we want is we want to increase this length, right? The vehicle be coming from here. Oh, why don't we do this? Yeah. Let's close the circuit. Let's see if this works. Wow. Yeah, it does work. Okay, so yeah, interesting. What we also probably need to do is give waypoints, a few more waypoints to the other vehicle, but let's see what happens with this. Okay, so as you can see, our ego vehicle has stopped, and yeah, unfortunately what we expected did happen. The simulation stopped. Let me give some more waypoints to this card. Yeah, add forward waypoints. Let's see if we can convert this to sort of a continuous motion. Right, let's try this. Let's close the circuit so that vehicle can keep on moving. Moment, I don't know if it is possible, but that will also increase waypoint for our vehicle. One more here. let us also see what happens if we just end here on another waypoint. Yeah. Okay, it doesn't look like it's going to continue, but well, for what it is worth, let's see. Oh wow, I'm making a turn like Formula car. Great, let's see. Right. Okay, so our ego vehicle has stopped for 3 seconds to let the other vehicles pass. What a good driver. Okay. Apparently it's very long in this simulation environment. Okay. This is interesting. All right. Let's do one thing. Let's just change this to something like 1. Yeah. 1 seems better in this situation. All right. So go to start and again we simulate. Yeah, great, perfect. Nice. All right. Okay. Let's go to start. Let's make it a bit more interesting here. Let's add some more actors. Let's add a bicyclist here. Okay. Let us change its orientation to 270. Right, and let's add some waypoints. Let's plan the trajectories of this other vehicle and the ego vehicle in something called as open loop manner here. Let's see if we can bicyclist doesn't follow the rules. Okay, seems good. Yeah. Okay, and our bicyclist has a speed of 5 km/h. Nope, they are at least 15 to 20. Okay, this is meters per second. Wait. Okay, so 20 kilometers per hour is 1000 by 3600. So something like 20 into 10 by 36. Okay, approximately. That's 5 meters per second. Wow. Okay. So let's keep it to 5 as it was. Let us also add another actor. Okay, a pedestrian. Nice. So pedestrian is here. Okay. And yeah, let's plan some route for him or her. This is a bit annoying because the pan doesn't work when you are adding waypoints. And she also wants to take a U-turn, again cross the road. Alright, and what is the speed? 1.5 meters per second. Okay, let's run the simulation. Let's see what happens. Okay. Great, there were no accidents. Perfect. Unfortunately, we might not be able to see our pedestrian cross the road, because by then the simulation is going to end. Okay, so cyclist made it. Pedestrian is still on the way to cross the road. And 3, 2, 1, over. Alright, so that's all in this video. The purpose was to just introduce you to the tool. Yeah, I had fun trying out this new tool. I hope you do too. Let me know in the comment. Yeah, here's your feedback, and I'll see you next time. Thank you very much.